In this video, we're going to look at some things that you should already be aware of, but we're going to look at them just a little bit differently, maybe look at them a little bit deeper than what we did in CPDM 151. And the first thing we want to look at is page directives. These are part of every ASP.NET page. You control the behavior of your ASP.NET pages by using these directives. There are 12 directives at your disposal in your ASP.NET pages or user controls. You use these directives in your applications, whether the page uses the code behind model or the inline coding model. You can see a sample of what a basic format of these directives are, and you've seen these used in CPDM 151, the @page directive, the @master directive. You've seen some of these already. They should always be at the top of the page, not because that's the only place that they work, but because that's where developers normally are used to looking for them. They would still work if you placed them somewhere else, but historically everyone puts them at the top of the page. You can also have more than a single attribute, as well as more than one page directive. Now, what these directives are really used for, first of all, they're really commands, and these commands then are used by the compiler when it actually compiles the page. So it's real important when this page is being compiled and generating a DLL file that all the information that the compiler needs is there, thus the page directives. The @page directive enables you to specify attributes and values for an ASP.NET page that are used when a page is parsed or compiled. This is the most frequently used directive, and because the ASP.NET page is such an important part of ASP.NET, there are quite a few attributes for the directive. You can find them all listed on pages 62 through 64. The @master directive is quite similar to the @page directive, except that the @master directive is meant for master pages. In using the @master directive, you specify properties of the templated page that you will be using in conjunction with any number of content pages on your site. Any content page built using the @page directive can then inherit from the master page all the master content defined in the master page using the @master directive. Although they are similar, the @master directive has fewer attributes available to it than does the @page directive. Those are listed on page 65. The @control directive is similar to the @page directive as well, except that you use it when you build an ASP.NET user control, such as the form control that we built in CPDM 151. The @control directive allows you to define the properties to be inherited by the user controls. These values are assigned to the user control as the page is parsed and compiled. The available attributes are fewer than those of the @page directive, but they allow for the modifications you need when building user controls. You'll find those on page 66. The @import directive allows you to specify a namespace to be imported into the ASP.NET page or user control. By importing, all the classes and interfaces of the namespace are made available to the page or user control. This directive supports only a single attribute, and that's namespace. The namespace attribute takes a string value that specifies the namespace to be imported. The @import directive cannot contain more than one attribute value pair. Because of this, you must place multiple namespace imports in multiple lines in order to get all the namespaces in the page that you need. There are several assemblies that are already being referenced by your application. You can find a list of these imported namespaces by looking in the root web config file. And you can find that file in your C drive, going to Windows, Microsoft.NET, Framework, pick the version 4.0, and then you're going to have point some other number after that. and then inside of that you're going to choose the config. You can see all the config files in here, including the web config. If we just open that real quick in Notepad++, you can see that this is just like the web config that you have in your page, written in XML. But as you scroll down, you will find all the assemblies that have been added, as well as build providers, which we'll talk about in the next video. Notice that these are actually being referred to through the compilation tag and the assemblies tag, the child element. Because of this reference in the root web config file, these assemblies do not need to be referenced in the references folder. You can actually add or delete assemblies that are referenced from this list. Although the assemblies might be referenced, you must still import the namespaces of these assemblies into your pages. The same root web config file contains a list of namespaces automatically imported into every page of your application. This is specified through the namespaces child element of the pages element, which you can see here, and you'll see that some of these are some that you've already used. You may not have known what was happening at the time in 151, but the code behind page automatically adds a couple of these for you automatically. Now you can modify this section in the root web config file, or even make a similar selection of namespaces within your application web config file. You can import your own namespaces in the web config file of your application to make the namespace available on every page where it is utilized. You do that through the configuration system web, compilation debug, the HTTP runtime, and then in pages, this is where you would use the namespaces to add whatever namespace you need to add. This is the preferred way rather than modifying or changing the root web config that's on your C drive. Most people just leave that alone, make the modifications on each application or project within the web config of that project. The @implements directive gets the ASP.NET page to implement a specified .NET Framework interface. The directive supports only a single attribute, that is the interface. The interface attribute directly specifies the .NET Framework interface. When the ASP.NET page or user control implements an interface, it has direct access to all of its events, methods, and properties. The @register directive associates aliases with namespaces and class names for notation in custom server control syntax. You can see the use of the @register directive when you drag and drop a user control onto one of your ASPX pages. Dragging a user control onto the ASPX page causes Visual Studio 2012 to create a register directive at the top of the page. This registers your user control on a page so that the control can then be accessed by the ASPX page by the specific name. You can see that in this example here where I've imported a control, which is the contact form control. You can see that over here as well under controls, and then by doing that it added this register, the @register. The @assembly directive attaches assemblies, the building blocks of .NET applications, to an ASP.NET page or user control as it compiles, thereby making all of the assemblies, classes, and interfaces available to the page. The @previous page type is used to specify the page from which any cross-page postings originate. We'll actually talk about cross-page posting in just a little bit. The @previous page type works with the cross-page posting capability that ASP.NET 4.5 provides. Has two attributes: the type name that sets the name of the derived class from which the postback will occur, and the virtual path, which is the location of the posting page from which the postback will occur. The @master_type directive associates a class name to an ASP.NET page to get a strongly typed references or members contained within the specific master page. It also has two attributes, the type name again, which sets the name of the derived class, and the virtual path, which is the location of the page where references and members are retrieved. The @output cache directive controls the output caching policies of an ASP.NET page or user control. And lastly, the @reference directive declares that another ASP.NET page or user control should be compiled along with the active page or control. This directive contains a single attribute, the virtual path attribute, which just contains a location of the page or user control from which the active page will be referenced. ASP.NET developers consistently work with various events in their server-side code. Many of the events that they work with pertain to specific server controls. For instance, if you wanted to initiate some action when an end user clicks a button on your page, you would create a button click event in your server-side code. In addition to the server controls, developers also want to initiate action at specific moments when an ASP.NET page is being either created or destroyed. The ASP.NET page itself has always had a number of events for these instances. Since the inception of ASP.NET, these events have been there. Now, a lot of these, some of these we've never talked about, some of them we may talk about in this class. Some that you actually should already be aware of is the load and unload. You've seen the load especially used quite a few times, but these are other events that developers need to be aware of. Besides the page events, ASP.NET 4.5 has these other events, the init complete, which indicates the initialization of the page is completed, the load complete, which indicates the page has been completely loaded into memory, the pre-init, which indicates the moment immediately before a page is initialized, preload, which indicates the moment before a page has been loaded into memory, and pre-render complete, which indicates the moment directly before a page has been rendered by the browser. If you create an ASP.NET page and turn on tracing, you can see the order in which the main page events are initiated. They are fired in the same order that you see here, from pre-init all the way down through the unload. This is the order that everything is fired. This is just a graphic of the same thing. With these choices now, you can work with the page and the controls on the page at many points in the page compilation process. Dealing with postbacks. When you're working with ASP.NET pages, be sure that you understand the page events just listed. They are important because you place a lot of your page behavior inside these events at specific points in a page lifecycle. In Active Server Pages 3.0, developers have their pages post to other pages within the application. ASP.NET pages typically post back to themselves to process events, such as a button click. For this reason, you must differentiate between posts for the first time a page is loaded by the end user and postbacks. A postback is just that, a posting back to the same page. The postback contains all the form information collected on the initial page for processing if required. And the way that you check that is to actually use a simple if statement. If it's not page is postback, that means it's loading, then you're going to do this. Cross-page posting. One common feature in ASP 3.0 that was difficult to achieve in early versions of ASP.NET is the capability to do cross-page posting. Cross-page posting enables you to submit a form and then have the form and all the control values post themselves to another page. Traditionally, any page created in ASP.NET 1.0 to 1.1 simply posted to itself, and you handled the control values within this page instance. You could differentiate between the page's first request and any postbacks by using the page is postback property that we just saw in the last slide. Even with this capability, many developers still wanted to be able to post to another page and deal with the first page's control values on that page. This is something that is possible in ASP.NET 4.5 and is quite a simple process. So one way to create an instance of the control in a new page is by using the postback URL and find control method of the previous page property. Another way would be to create a property for the control and utilize the previous page type directive.